Alright guys, we've been finding the last several sections, about 4 lessons here, surface area and lateral area. Well, now we're going to go three-dimensionally and find volume. I want you to remember what volume is really doing. Remember, when we had area, we're literally counting the number of squares that we're working there. But when I make it three-dimensionally, what I'm trying to do is really count the number of cubes that make up the value. So we have the exact of cubic units that we do. And another thing we're going to use is the fact that we can work with right or oblique or regular or non-regular figures. So here's the example I'm going to use with you. So please kind of give me a little bit of leadway here. When I use a deck of cards, basically that makes, if I put it up perfectly like this, a rectangular prism. I can find its volume by finding the area of the base times the height. Now here's my question. If I slant it like this, do I still have a prism? Yeah, I still have parallelograms, quadrilaterals making the sides. I still have my 2 exact bases. In fact, it's the same height because I have the same number of cards. So when I do that, do the deck of cards, did it change volumes? No, it didn't change volumes. In fact, it stayed the same. Well, that is called Cavalaris Principle. What Cavalaris Principle says, if I have 2 shapes that have the same size bases, that no matter what, where I cut those bases, if I get the same thing, now if I was slanted or whatever, if I get the same amount, the same height, and I get the same thing, my 2-dimensional cross section stays the same shape. So in this case, it would be a card. Remember, I can have it right, or I can have it slanted, and I can have my cards here. I will have the exact same volume. Just because it's slanted does not mean it has a different volume than when it is going straight up and down. That's called Cavalaris Principle. So let's write Cavalaris Principle down. They're using here some triangular prisms to describe what those are, but it kind of works the same way. So let's go real quick. So this Cavalaris Principle says that if 2, 3 dimensional figures have the same height, in which they did with the deck of cards, and have the same cross sectional area, at every level, then they have the same volume. So now I don't have to have perfect looking prisms. I don't have to have right prisms. I can have oblique prisms. Same type of idea. Now I want to remind you what we put on the last, I'm trying to find my notes that I just did last on here. Excuse me, on 10.4a notes. What's the process of solving for volume and lateral area? It's right here. It says how to find lateral and surface area volume of prisms and pyramids. First you have to draw the base. Then you find the perimeters and area of the base, and then write your formulas and then plug and check and label correctly. This process I'm going to use is going to stay the same. Now the cool thing is I can throw out perimeters sometimes. Not every time, but sometimes, and that's going to be really huge. So, how do I find the volume of a prism? It is so easy. The volume is area of the base times the height. The base, area of the base, is what the figure that we have, and how tall the prism is, the height. That's how you find its volume. And you actually did that with rectangular prisms pretty easy. Now here I have the volume of a cube with its edge length s. Well, our base is a square, so side times side is side squared. I multiply by the height of s. The volume is going to be side cubed. So I thought, that's pretty easy to do. We can use that to our advantage. So when I do this, the process stays the same. It says, find the volume of the prism, round to the nearest tenth if necessary. Well, just like anything else, we're going to find the base. Now the cool thing is, with volume on a rectangular prism, it doesn't matter which side you choose as your base, you're going to get the right answer. So I always pick just the bottom because it keeps it easier for me. So I can find the area of my base, which is base times height. That's 13 times 3 equals 39. And then I'm going to plug it into my volume formula. Area of the base times the height. If this is my base, this has to be my height. So I got 39 times 5. I got 195, and don't forget to label correctly, cubic, make sure it's a capital E, centimeters. Now, someone said, Mrs. Gregerson in class, what if I used this for my base? Okay, 5 times 3 is 15. 15 times 13 is going to give you 195 cubic centimeters. So that's one reason why you should always draw your base. Now, with this one, I'm just going to go through and work a couple of these problems, and then we're going to do cylinders separately here. It says, find the volume of a cube whose edge length is 15 inches. We love it when they use cubes. Now, if you want to draw the cube, great. But for me, I just want to remember, you know, basics, what it says. The volume of a cube is just side cubed. So I'm going to go 15 cubed. So that's going to end up being 3,375 cubic inches. Don't even have to draw the base because it's a cube. All right. Now, some of you are still struggling to tell me what a base of a prism is. A lot of times I name it so you know which one it is. On this one, it tells you, it doesn't really tell you, but you should realize it, because the definition of the bases of a prism are the two congruent, parallel polygons. Well, are any of the rectangles parallel? No. So automatically that makes it your base. So you draw it. And I have this equilateral triangle that I'm drawing, and you should know by now, if I have an equilateral triangle, it's equiangular. So then I draw in the height of it, because I have to find it, because the rule says draw your base, find perimeter and your area of your base. Well, I have a 30, 60, 90 triangle. The height would end up bisecting this side, so that's 2. Well, to get from the short leg, because it's opposite 30, to the long leg, because it's opposite the 60, it's going to be 2 root 3. The area of my base is 1/2 base times height. So 1/2 the base, which is going to end up being 4, not 2. I have to use the whole side of the triangle, times the height, which is 2 root 3. So the area of my base is 4 root 3. So my volume is actually really easy to get. Area of the base times the height. So I get here, my area of my base is 4 root 3. My height is how long the prism is, or how tall the prism is. That's 9 meters. That's 36 root 3 cubic meters. All right, we're going to sit there and we're going to turn around and do the same thing with cylinders.